Hello students, welcome you to this session. Now today's class we are going to study entirely a different one. Rank of a matrix. How to find rank of a matrix. That's what we are going to study today. The second exercise is main about this one, rank of a matrix. To find rank of a matrix, there are two methods. One method is using determinant. Using determinant method, or we call it as minor method. Okay, using determinant method, another name is minor. And there is another method, it is called row reduction method. Row reduction method, and I'll explain to you a little later, okay, with some example. Okay, now we just remember there are two methods to find rank of a matrix. One method is determinant method and another method is what? Row reduction method. In row reduction method, what we are doing, just to explain to you, in row reduction method, we reduce the given matrix into a form called echelon form. Something new, right? Echelon form. What is echelon form? You know, in a matrix, you make the first element as 1. You make the first element as what? 1. Below that, all the elements you have to get 0. Then second row, second element you make it as 1. Below that 0. Above that no problem. Whatever it is, no problem. Third row, third element you make it as 1. Above that any number, no problem. Listen again. First row, first element you have to get 1. Below that you have to get 0. Second row, second element is 1. Below that 0. And the third row, third element is what? 1. If you are able to write like this form we call it as what? Echelon form. And another name of echelon form is what? Triangle form. Echelon form, or we call it as what? Triangle form. To reduce it into this echelon form, we use some transformations. And that transformations we call it as what? Elementary transformation. We call it as, and that method, elementary transformation method. Okay, so row reduction method, or what's another name? Elementary transformation method. And you must know what are the elementary transformations. Next I'm going to explain that. Okay, I said we can make some changes. You cannot simply make any change as you like. There are three changes are allowed. So 3 transformations are allowed. That transformations we call it as what? Elementary transformations. What is the use of that? To reduce the given matrix into echelon form. What's another name of echelon form? Triangle form. So listen, to find rank of a matrix, there are two methods. The first method is determinant method. I didn't explain anything about that. I'll tell you a little later. Second method is row reduction method. We are using only row here. Okay, row reduction method. Another name is elementary transformation method. Using that method, we reduce the given matrix into echelon form. After reducing echelon form, how can you identify rank of the matrix? Before that, I'll tell you one thing. How to denote rank of a matrix? Rank of, suppose A is a matrix. A is a given matrix. Rank of the matrix, we denote it as row of A. You read it as what? Row of A. When you reduce it into echelon form, I said the first element is what? 1, right? First element is 1. Below that you have to get 0. Second row, second element 1. Below that you have to get 0. Third row, third element, make it as 1. Below that, if anything is there, you make it as 0. Here nothing. Here and now, whatever element, no problem. 10, 4, 7, 6. Okay, it is in echelon form. It looks like a triangle, right? So we call it as what? Triangle form also. Now, how can you identify the rank? You count number of non-zero rows. What is 0 row? Suppose a row fully 0, that is called 0 row. Non-zero row means at least one element is not equal to 0. First is non-zero row. Second is also non-zero row. Third also non-zero row. So in this case, we say rank of the matrix is equal to what? 3. Because number of non-zero rows equal to 3. Then, in that process, suppose you get these two elements are zeros. Now, how many non-zero rows? Only 2 non-zero rows, right? In that case, we rank is equal to 2. Suppose second row also fully 0, we say the rank is 1. So, like that, you can find the rank using row reduction method. And I said there is one more method, the first method, that is what? Determinant method. Just to explain to you what is determinant method. It's a very simple one. A matrix is given. First step, you check the order of the matrix. Order of the matrix. So it is a 2 by 3, right? 2 by 3 matrix. Now among these two, you see which is a smaller number. 2 and 3, which is a smaller number? 2, right? 2 is the smaller number. So rank is 2 or less than 2. Rank cannot exceed 2 here. Okay. So first you find the rank of the matrix, number of rows, number of columns. Among that two numbers, you see which is smaller. You may ask, sir, if it is 3 by 3, what to do, right? If it is 3 by 3, both are same, smaller number, you take it as 3, right? If the numbers are different, you take the smaller, which is a smaller number here, 2. So the rank is either 2 or less than 2. Either 2 or less than 2. Less than 2 means it can be 1, it can be even 0. How to confirm it? First we have to check for 2. For that, you take a 2 by 2 minor. You know what is minor, right? You leave some row and column, you take. So 2 by 2 minor, okay, you take a 2 by 2 minor like this. You take a 2 by 2 minor. Only these 4 numbers, okay? You take a 2 by 2 minor. Expand. You know how to expand a determinant, right? Expand and see what answer you get. You get some answer which is not equal 0. Which is not equal 0. It is confirmed. The rank is 2. Suppose the determinant value is 0. You don't say rank is not 2. You check for some other 2 by 2. This 2 by 2 you take, suppose it is 0. Then you take this 2 by 2. This 2 by 2 you take. If it is not equal 0, the rank is 2. If that also 0, you take one more 2 by 2, right? First column and the last column. This and this alone you take. Another 2 by 2 can form. If that is not 0, again the rank is what? 2 only. When we say rank cannot be 2, if all the 2 by 2 minors you take, everything vanishes, everything becomes 0, then you say rank is not equal to 2. If all the 2 by 2 minors are zeros, then rank cannot be 2. Then what you have to check? Already I said, right? Maximum it is 2, 2 or less than 2. Next you check, rank is not 2. Okay, next you check for what? 1. 1 means you take 2, I said you take a 2 by 2 minor. For 1 you take a 1 by 1 minor. 1 by 1 means single element, right? Single element, just one element you take. Or 1 by 1 minor, or we take it as Aij. Or we take it as what? Aij. At least one element not equal to 0, then you say the rank is equal to 1. At least one element not equal to 0, we say the rank is 1. When you say the rank is 0, if all the elements are zeros, we say the rank is equal to 0. Okay, so like this you can find rank using determinant method, or another name is minor method. See once again. Suppose a matrix is given. You find the order of the matrix. Suppose the order is m by n. Among these two numbers, you see which is a smaller number. Suppose m is the smaller number, then the rank is either m or less than m, right? To check whether the rank is m or not, you take m by m minors. If at least one m by m minor not equal to 0, it is confirmed the rank is what? M. If all the m by m minors are zeros, rank cannot be m, right? So now reduce 1. If it is 3, you go for 2. If it is 2, you go for 1. Like that you have to check 1 by 1. Okay, so this is determinant method. Another method I said, row reduction method, or we call it as elementary transformation method. There we reduce the given matrix into echelon form. To reduce it into echelon form, then after getting echelon form, already I said how to find the rank. But only thing I want to teach you, how to reduce it into echelon form. For that I said we make use of elementary transformations. Now you need what are that elementary transformations. So you see what are the elementary transformations. I said there are 3 elementary transformations. The first transformation is 2 rows can be interchanged. Suppose you have 2 or 3, 2, 1, 5. Second row 1, 3, 4, 5. Then 2 minus 3, 7, 6. I want the first row, I want the first element as 1. But 1 is not here, right? How can you make it as 1? One method, you divide by 3, you can make it as 1. If you divide by 3, everything you will get fractions, right? Then the remaining calculation will be tough. So don't divide it. If no other way, go for that. Now here there is the first elementary transformation. It says 2 rows can be interchanged. 2 rows can be interchanged. So here we have a 1, right? You can interchange first row and the second row. You can write symbol like this, R. This is the symbol for that. You are interchanging first row and second row. First row you change it as second row, and second row you change it as what? First row. So 2 rows can be interchanged. That is the first transformation. There are 3 elementary transformations. The first one is any 2 rows can be interchanged. Okay. So if you interchange, you may ask, so the matrix changes? Yes, matrix changes, but it won't affect the rank. So the next matrix, after interchanging you get a matrix. No, we won't put equal to here. This is A is equal to this matrix. When you give some transformation, it won't be equal to the next matrix. So we use the symbol like this. It is equivalent to next matrix. What change we are giving? Interchanging first row and second row. So second row goes up, right? 1, 3, 4, 5. First row comes down, right? 3, 2, 1, 5. We are interchanging first row and second row. Third row, no change. 2 minus 3, 7, 6. Okay, hope you understood the first transformation. 2 rows can, what change you make, you have to write here. So we are interchanging R1 and R2. Okay, so adjacent to that, you have to write. In 11th standard also you did that, right? So what change you make, that changes you have to mention. So this is the first transformation. Now we see the second transformation. One row can be multiplied by some number. Multiply means you can divide also, because division is also multiplication, right? You are multiplying by a fraction. So one row can be, that's what I said. Suppose you want, you can divide by 3. Suppose something is common, if you want, you can divide or you can multiply. One row can be, suppose second row I am multiplying by 7, then second row is 7 into R2. Like that you write the symbol. Okay, so that is the second transformation. So first one is 2 rows can be interchanged. Second one row can be multiplied or divided by a number. And the third one is 2 rows can be added or 2 rows can be subtracted, or 1 row is equal to 1 row plus some constant into another row. Like that also you can do. 1 row can be written as for example, second row is equal to second row minus 3 times R1. These type of transformations, 2 rows can be added, 2 rows can be subtracted, or multiply by some number and add, or multiply by some number and subtract. All these are allowed, and this is the third transformation. Okay, Ri is equal to, right? Ri is equal to Ri plus K Rj. Ri, Rj, 2 rows. That's all. Okay, so these are the 3 transformations. Look again. What's the first one? 2 rows can be interchanged. 2 rows can be interchanged. And what's the second one? 1 row can be multiplied or divided by a number. And what's the third one? 1 row can be written as the sum of 2 rows or difference of 2 rows, or multiply by some number and add or even subtract. So that is very useful one, because so listen, suppose it is 7 here. I said earlier, I said put 1 here, right? So I want the first number as 1, so I can interchange, I said. But if it is not 1, what do you do? There are different methods. Okay, now listen here. Here 3 is there, here 2 is there, right? Subtract 3 minus 2, it is 1. So what step you write? R1 is R1 minus R2, right? R1 is R1 minus R2, because not R2, R3. R1 is R1 minus R3. So 3 minus 2, right? 3 minus 2 is what? 1. Suppose here also, suppose 2 is not there. Some number, say 5. We want to make it as 1. How can you make it as 1? Can you find out some method here? Listen, here 7 is there, no? You multiply by 2. That is allowed, right? Second transformation, one row can be multiplied. If I multiply with 2, I'll get what? 6. Then subtract these two. 7 minus 6, you will get what? 1. Then you can interchange. So any method, so here for that there is no formula. Here only your skill. So you have to develop. Every sum you'll have different situation. So the method is first row, first element you make it as 1. Below that we have to make it as what? 0. Second row, second element 1. Below that 0. Third row, third element 1. If you are able to write like that, we say it is in echelon form. Then count the number of zeros. Number of non-zero rows. Number of non-zero rows. If everything is 0, rank is only 2. Here also 0, rank is 1. Okay, like that you can identify. This is very important one. In all the remaining exercise also we use this one. First exercise cofactor very important we said, right? Same way hereafter in all the remaining exercises reducing into echelon form, that is very important. So you have to practice more. Okay. So to find rank, two methods we studied. One is determinant method, another method is elementary transformation method. So we are going to do sums based on that. And one more thing we are going to study, Gauss-Jordan method. The first two used to find rank, right? But this is used to find inverse. This is used to find what? Inverse of a matrix. To find inverse, already you studied two methods. One is if A is given, how to find A inverse? You know the formula, right? 1 by determinant A into adjoint A. Same way, if adjoint A is given, how to find A inverse? Last class we studied all those things. But here, there is another method to find inverse. And here the method is called what? Gauss-Jordan method. So you read the question very carefully. Someday they give A. They will ask you find the inverse of A using Gauss-Jordan method. Then you must use only this method. I will tell you what is this method. Please listen here. A matrix is given. Listen, a matrix is given. You find A bar I. It's an augmented matrix. A you write. What is given here? That A you write. Whatever matrix they give, you write. Here they give the square matrix. Because I we are using, right? In this method, they'll only for square matrix inverse exists. We studied, right? Because two conditions we said. Inverse exists only it is non-singular and square matrix. Okay, a square matrix is given. We are going to find the inverse of this. Rank you can any matrix they can give. But to find inverse, they give only square matrix. Now put a line here and you write I, it is I3. If it is a 3 by 3 matrix, you write I3. If it is 2 by 2, you write I2. You here assume there is a 3 by 3 matrix. Then here you write what? I3. So I3, you know, 1 0 0 0 1 0 0 0 1. This is A bar I3. Now what do you do now? So reduce this part into echelon form. This is A, right? This is A given. This is what A given. You reduce it into echelon form. First row, first element you want to make 1. Suppose you interchange first row, second row. The whole thing we change. We are not going to change this alone. We are going to change the full row. If you want to multiply, you multiply the full row. So when you make some change, it will make changes here also. Our aim, we reduce it in echelon form first. 1 0 0 1 0 here 1. Then automatically all these things will change, right? These elements also will change. Now try to make these three elements also zeros. When you find the rank, I said any number you can get here, right? But here, you later, after finishing up to this, we try to make these numbers also zeros. How we will see? When you do the sum, you can understand better. When you make these changes, it will affect totally, right? Earlier we had taken the identity matrix, now we change totally. Now this is the identity. Whatever you get here, that is A inverse. Okay, this is A inverse. So this method we call it as what? Gauss-Jordan method. A matrix is given. Take the matrix as A. You find A bar I3 or I2, identity matrix. Whatever be the order here, same order identity you take. So given matrix, identity matrix. Now just draw a line. That's all. But you treat it as a full matrix. Don't interchange any columns. Only rows you have to use. Use elementary transformations, reduce it into echelon form first. After reducing into echelon form, you make these numbers also what? Zeros. Then what you get here at that time, the resulting matrix here, that is what? A inverse. Okay, that's the theory part. we studied today. Based on this only, we are going to do sums. Okay, so listen, only two things I taught. One is how to find rank. Second one, how to find inverse using Gauss-Jordan method. To find rank, there are two methods. One is determinant method or minor method. Another method is row reduction method or elementary transformation method. Okay, so to find rank, there are two methods. Then we studied how to find inverse of a matrix using Gauss-Jordan method. Okay, so now we go to the second exercise. Only three questions given here. The first question is to find rank. Find the rank of the matrices. You read the question very carefully. Here they specified find the rank of the matrix using minor method. Minor method or determinant method, right? Both are same only. If nothing is specified, you can use any method. Okay. So we take this question, first question. A equal to 2 minus 4 minus 1, 2. So one matrix given. Determinant method, what's the first step I said? You find the order of this matrix. Find the order. What is the order of this matrix? 2 by 2, right? Because there are 2 rows and 2 columns. So the order of the matrix is what? 2 by 2. Now, among these two numbers, you see which is smaller. Here only two numbers, both the numbers are same. So which is the smaller? 2, of course. We take it as what? 2 only. So now the rank is either 2. Rank is either 2 or less than 2, right? Either the rank is 2 or less than 2. Less than 2 means it can be 1, it can be 0. But first you check for what? 2. 2 means you take a 2 by 2 minor. You take a 2 by 2. Here you have only one 2 by 2, right? But if you have something like this, we have a 2 by 2 like this, right? We have a 2 by 2. We have a 2 by 2 like this. We have a 2 by 2. There are 3 possibilities. But here we have only one 2 by 2. So write that 2 by 2 minor. Expand and see what you're getting. 2 into 2. 4 minus minus minus. So 3 times minus, so it is minus. 4 minus 4, you are getting what? 0. So 2 by 2 minor we have taken. We got the answer of what? 0. So we check any other 2 by 2 minor. Here there is no other 2 by 2, right? You can't make any other 2 by 2. Here you can make it. But here you can't make any other 2 by 2. So the rank cannot be 2. Rank not equal to 2. Row of A. Rank cannot be 2. Rank cannot be 2 means next you check for what? 1. 1 means 1 by 1. Single element. A, I, J. At least one element. There are 4 elements. Even one element is not equal to 0. You say the rank is 1. Okay, so here, but you write like this, okay, but at least one Aij, that is 1 by 1, is not equal to 0. So you can conclude like this, rank of A is equal to 1. Okay, look once again, your 2 by 2 matrix is given. It's a very simple question, it's a 2-mark question, 2 by 2 matrix. First steps you write properly. First you find the order. What's the order here? 2 by 2. Among that 2, smaller number is 2 only. So rank is either 2 or less than 2. So take a 2 by 2 minor. That is only one 2 by 2 minor here. Expand it, you are getting 0. If it is not equal to 0, rank is 2. Here it is 0, so no other 2 by 2. So rank cannot be 2. Then go one step down, 1 by 1. Single element, Aij, it is not equal to 0, so the rank is 2. So the rank is 1. Shall we go for the next sum? Similar method, another question. A equal to minus 1, 3, 4, minus 7, 3, minus. First step, you have to check the order. What is the order here? There are how many rows? 3 rows, right? First row, second row, and third row. There are 3 rows, but how many columns? Only 2 columns. So the order is 3 by 2. So the order is 3 by 2. 3 and 2, which is a smaller number? 2. So the rank cannot be 3 here. Among the 2, the smaller number is only 2. Order is 3 by 2, the smaller number is what? 2. So rank is either 2 or less than 2 only. So first you check 2 by 2. Please listen here, we have minus 1, 3, then 4 minus 7, 3 minus 4, right? 2 by 2 means, listen, this is a 2 by 2, this is a 2 by 2, and this is like that, you take 2 by 2, right? Suppose here So minimum value is 2, so the rank is either 2 or less than 2. Take a 2 by 2 minor. The first one you are taking minus 1, 3, minus 1, 3, 4, minus 7. If you expand, multiply these two, right? Minus into minus plus. So 7, minus 4 3s are 12. 7 minus 12, it is minus 5. It is not equal to 0. So it is confirmed the rank is what? 2. Suppose it is 0. Don't say rank cannot be 2. You check for some other 2 bit. I said here you have this is a 2 by 2. Leave this. So another 2 by 2. Leave this. Another 2 by 2. Right. So there are 3 possibilities. There are 3 2 by 2. If all the 3 by 3, all the 3 2 by 2 minors are zeros, then only you have to say rank cannot be 2. Okay. So here you say the rank of A. Rank we denote it as row. It write like this. Row of A equal to 2. Rank of A is equal to 2. Now we see another question, the same type, but different order. See, 1 minus 2 minus 1 0. First row. And what's the second row? 3 minus 6 minus 3 1. Right? 3 minus 6 minus 3 1. So using determinant method only, so the first already we did 2 sums. First you check the order. What is the order here? How many rows? 1 row, second row. There are 2 rows. 2 rows and 4 columns. 2 rows and 4 columns. Among that, which is a smaller number? 2. 2 is the smaller number, so rank is either 2 or less than 2. You take this 2 by 2. What happens you see? 1 into minus 6, minus, here another minus 6, right? So it becomes plus 6. So it is what? 0. Don't simply say rank cannot be 2. Check another one. You take this one. Minus into minus plus 6. Minus into minus plus. So no change. That also 6. That also 0. Sometimes what happens, you find 1, 0, second find 0. Then we confirm, right? Everything 0. Rank cannot. Don't check everything. You take this one. Minus 1 into 1. Minus 1. Minus 0 into anything 0. So what you are getting? Minus 1, which is not equal to 0. You have to be very careful in this one, okay? So for this sum, first you find the order, right? What's the order here? 2 by 4. There are 2 rows and 4 columns. So 2 by 4, the minimum among that 2, it is 2. So rank is 2 or less than 2. So take a 2 by 2. 2 by 2 minor, take first 2 by 2, you are getting 0. Second, another one we take which is not equal to 0. If you are able to identify which is not equal to 0, that alone you write, that's enough. Okay, but you take. But if it is a 3 by 3 or 3 by 4, something like this. If they give a matrix like this, 4 rows, 3 rows but 4 columns. What is the order here? 3 by 4. Which is the smaller among these two? It is 3. So rank is either 3 or less than 3. So take a 3 by 3. Okay, normally we take the first 3 by 3 like this, right? You take a 3 by 3. 3 by 3 you cannot do like 2 by 2, right? 2 by 2 you can do very easily. By 3 by 3 it takes some time to do very carefully, right? Suppose it is 0. What will you do? You go for another 3 by 3. And how many 3 by 3s are there? Can you find out how many 3 by 3s will be there? Listen, leave this. You are getting a 3 by 3, right? Leave this one. You are getting a 3 by 3. Leave this, a 3 by 3. Leave this, 3 by 3. So you can find out 4 3 by 3 minors. 4 3 by 3 minors, right? Like this, you find 4 times you find out. If everything 0, then only we say the rank not equal to 3, right? But suppose by some mistake you make, you get some number, we will think the rank is equal to 3, right? You have to be very careful. It's a tedious work. That is why if nothing is specified for these type questions, better you go for another method, okay? What's that method? Elementary transformation method. So that's a drawback for this method, okay? If a question is like this, then sometimes it takes a lot of time, okay? So that's all about finding rank using determinant method. Now we go for the second method. Again finding rank only, but using Which method? Using elementary transformation method. But for it's a very simple question. Yeah, 3 by 3 sum is given. 3 by 3. I think you can take it as a homework and you can do that. Anyway, just to explain to you. It is a 3 by 3. It is only one 3 by 3 is there. So check whether the rank is 3. So take that 3 by 3 minus first itself you are getting 4. The calculation but I didn't do, you complete that fully. Okay. It is not equal to 0, so it is confirmed the rank is 3. Okay. So that's all about rank method, determinant method. Now, find the rank by row reduction method. Row reduction method. Just recall what's the theory part for this. What is row reduction method, or another name, elementary transformation method. What are elementary transformations? There are 3 elementary transformations, right? What's the first one? 2 rows can be interchanged. Second, 1 row can be multiplied or divided by a number. What's the third one? 2 rows can be added or subtracted or multiplied by some number and add it. Okay, so these are elementary transformation. What's the use of this? Using these elementary transformations, you reduce the matrix into a form called echelon form, right? So after reducing into echelon form, you count how many non-zero rows. And you can say that is the rank. If there are 2 non-zero rows, you say the rank is 2. Okay. Now see the first question. This is the first question. A equal to 1, 1, 1, 3. 1, 1, 1, 3. Second is 2 minus 1, 3, 4. And the third one is 5 minus 1, 7, 11. So this is a matrix. Listen carefully, reduce. So method they specify. Which method you use here? Row reduction method. So you cannot use determinant method here. First row, first element. So this is the first question. So listen very carefully. As I said earlier, this method is very important. That not only for this exercise, for the remaining exercise also we use this one. Okay. First row, first element we want 1. Already it is 1. Now our aim is to make the other 2 elements what? Zeros. So this is the given matrix A. Given matrix is A. First row, first element 1. So don't change the first row. First row you write as it is. 1, 1, 1, 3. I want to make this a 0. How can you make this number as 0? Use this 1. 2 minus 2 is what? 0, right? 2 minus 2, 0. So what you can do? Multiply by 2. Multiply by 2 means not only that element, that full row you multiply by 2 and subtract it. 2 minus 2. How can you make it a 0? 5 minus 5. Multiply by 5 and subtract. So first we make this 0. First row, first element 1. That row you write as it is. Below that we want to make both the numbers what? Zeros. This 2 we want to make it a 0. 2 minus 2. So what step you write? Second row is second row minus second row minus 2 times first row. Second row is second row minus 2 times first row. So multiply by 2 and subtract. If you want, you write the steps. Second row first. What is second row? 2 minus 1, 3, 4. Second row. 2 times first row. First row you multiply by 2. First row you multiply by 2. 2, 2, 2, 6. 2, 2, 2, 6. Now you have to subtract them. When you subtract, you change the sign. 2 minus 2, 0. Minus 1, minus 2, minus 3. 3 minus 2, 1. 4 minus 6, minus 2. That elements you can write here. Initially you can start like this, but you can do directly also. Listen, 2 minus 2. Remember, you have to multiply by 2 and you subtract. So 2 minus, multiply by 2, 2. So 2 minus 2, 0. Minus 1, minus 1, minus 2 times this. 2 into 1, 2. So you are getting minus 3. 3 minus 2 times this. 2 into 1, 2. So 3 minus 2, 1. 4 minus 2 times this. So 4 minus 6 minus, like that you can write. So by practice. Okay, so only thing, see that you are not making mistake. Okay, this is the basic method. Initially, if you want, you can start like this, then you do like this. After that, advance by seeing that you can write. But see that you don't make mistake. Look at the next one. 5 is here, no? First row, first element 1, below, first row, first element 1, below that make 0. This already made 0, right? Now I want to make this also 0. How can you make this 0? Make use of this 1. 5 minus 5. 5 minus 5. Can you tell me what step you write here? R3 is 5 minus 5. R3 minus 5 times R1. R3 minus 5 times R1. Okay, now listen here. Let us try this method. Okay, directly. 5 minus 5. This one you are going to write, then put a minus sign, multiply by 5 and write. So 5 minus 5, 0. Remember, 5 minus 5. So minus 1 minus 5 times this. 5 times, 5 into 1, 5. So minus 6. 7 minus 5 times 1. 5 ones are 5. So 7 minus 5 it is 2. 11 minus 5 times 3. 5 threes are 15. So you are getting minus 4. Okay. So like this you can reduce it. The first step, first row, first element 1, below that 0. Right. Let us see how we did. Hope you understood this method. Okay. So first row, first element 1, below that you make it as what? 0. Then next what I said, second row, second element, you make it as what? 1. Second row, second element, you make it as 1. Here the second row, what you are getting here, third row you are getting 0, minus 6, 2, minus 4, right? What is common here? Minus 2, right? So we are dividing that by minus 2. So that is the second elementary transformation, right? What is the second elementary transformation? One row can be multiplied or divided. Here, this is the step I explained first. Okay. Now here, what is common here? 2 is common. So by minus 2 we are dividing. So we are getting this step. Okay. Now 3 is here, minus 3 is here. If you add these two, you will get the last row fully what? 0. Okay, so you are getting like this 1 1 1 3. First row is 1 1 1 3. Second row is 0 minus 3, 0 minus 3, 1 minus 2, right? 1 minus 2. Last row fully you are getting what? 0. I said first row, first element 1, below that 0. Second row, second element 1, below that 0. Okay, below that 0 you got it. This number to make it as, either you make it as 1 or you leave it, no problem, they will give mark. But if you want, if you want to make it as 1, now no other way, don't disturb all these things. First row, first element 1, below that 0 means that's all. You should not use this part. Only this you have to use it. Here if something is there, you can use it. But nothing is there, you cannot make it in any other way. Only way, if you want, you can divide by minus 3. R2, you can divide by minus 3 so that you will get what? 1. No other way. Or even you can leave like this. So first non-zero element, below that you must get what? 0. First row, first element 1, below that 0. Second row, second element 1 or some non-zero element, below that you have to get what? 0. Okay. If you want to make it as 1 by dividing by minus 3. So this step, with this step you can stop, and last row fully 0, right? So you cannot proceed, third row. Now the steps what you write. Don't, now by seeing is, there are, the rank is what? Only 2, right? Because last fully it is what? 0. But you write the steps. 3 lines you have to write. This form is called what? Echelon form. It is in echelon form that you write first. Now you count how many non-zero rows. Last row fully 0. Leave that. Other 2 rows. So number of non-zero rows equal to 2. Therefore, rank of the matrix is equal to 2. So these are the 3 lines to write. Okay. So first, the given matrix, reduce it into echelon form. Then you write the 3 lines. It is in echelon form, number of non-zero rows 2, and the rank is equal to 2. Okay. So, but more sums you have to practice. We will see another question. Look at this question. A equal to 3, 2, 3 minus 8, 5, 2. Second one, 2 minus 5, 1, 4. And the third one, minus 1, 2, 3, minus 2. You try to find some way. First row, first element. Previous sum, first row, first element 1, right? but here not 1. How can you make it as 1? What are the possibilities you think? Here I want 1. How can you bring 1? You can't divide by 3. Okay, don't divide by 3. Then all the terms will become fractions. Then the remaining calculations will be tough. If something is common, you can divide it. Yes, there are different ways, right? One method, 3 minus 2, right? 3 minus 2, you will get 1. So what your step you can write? R1 is R1 minus R2. R1 is R1 minus R2. 3 minus 2 is 1. Another method, add these two, right? 2 minus 1. 2 minus 1 is what? 1. You will get 1 here, then you interchange. Otherwise, interchange first row and third row. First row and third row interchange. So minus 1 you will get there. Then you multiply by minus 1. Right? So it becomes plus 1. So there are different ways there, this case. But 3 minus 2, okay, directly you can do that. So what we do here? 3 minus 2, that is R1 is R1 minus R2. 3 minus 2. So R1 is R1 minus R2. Listen how we are getting 3 minus 2. 1 minus 8 minus 5. So calculation do very carefully. So minus 3, right? So that is why. Then 5 minus 1. 4. 2 minus 4 minus 2. Like that you are getting the first row. No changing second. 2 minus 5 1 4. Minus 1 2 3 minus 2. First row, first element 1. Below that you want to make these two elements what? Zeros. Listen how to do this. First row we got 1, no? So don't disturb that. 1 minus 3 4 minus 2. We want to make 0 here. How can you make it 0? Like previous question. Use this one. 2 minus 2. 2 minus 2. Multiply by 2 and subtract. So second row 2 minus 2. So what step you write here? R2 is 2 minus 2 times this. So 2 minus 2. So R2 is R2 minus 2 times R1. 2 times R1. 2 minus 2. So listen how to fill that one. If you want to write the steps. Remember, so keep on reading this. 2 minus 2. 2 minus 2. 2 minus multiply by 2. So this row minus 2 times the previous one. So 2 minus 2, 0. Minus 5. Minus 5 minus 2 times this. So minus 6. Minus minus plus 6. So you will get 1. 1 minus 2 times this. 4 2s are 8. So minus 7. 4 minus 2 times this. So minus 4. So put plus 4. You will get what? 8. 4 minus then 2 times this. So minus 4, right? So minus minus plus 4. So it is 8. Now, first row, first element 1. Below that you want to make 0. Both you have to make it 0. Okay, this we made it 0. 2 minus 2. How can you make this 0? Very simple. Minus 1 plus 1. Just to add these two. That's why. See the sum. The method will change for every sum, right? So depends on the values what you have. Minus 1 plus 1. Add these two. So what step you write here? R3 is R3. Write one below the other. Okay. R3 is R3 plus R1. R3 plus R1. Add these two. Minus 1 plus 1. 0. 2 minus 3. Minus 1. 3 plus 4. 7. Minus 2 minus 2 minus 4. So first row, first element 1. Below that 0. Second row, second element 1. Below this I want to make 0. Listen, already first row, first element is 1. Below that 0. Don't disturb this part. Don't disturb this. Only this you see. Only this part you can make changes. Okay. Here this element is 1. I want to make this 0. How can you make 0? Use this one. Don't go for other rows and all. Okay. Using this one you make 0. Very simple. Add these two. Adding these two. So what do you get here? Listen. So first row no change. 1 minus 3 4 minus 2. 1 minus 3 4 minus 2. First row. And what is the second row? 0 1 0 1 minus 7 8. And the third row we are adding these two. So R3 is R3 plus R2. R3 is R3 plus R2. So if you add, what you get? 0 plus 0, it is 0. Minus 1 plus 1, 0. 7 minus 7, 0. Don't put everything 0. First 3, 0. See the last one. Minus 4 plus 8. Minus 4 plus 8 is what? 4. First row, first element 1, below that 0. Second row, second element 1, below that 0. Third row, third element 1. If not, if it is 0, it's okay. Then first non-zero element, whatever it is, okay. Below that, if something is there, you must make it as 0. Here nothing there. If this number, if you want, you can make it as 1, like previous question what I said, or even if you leave like this, they give mark. To make it as 1, it's not a tough thing. Third row, you divide by what? 4. So no change in first and second. Third row alone, you divide by 4, what you get? 0, 0, 0, 1 you get, right? So then you can say the 3 steps I asked you to write. What are the 3 steps? It is in echelon form. Number of non-zero rows, 1, 2, 3. Even one element is non-zero, it is a non-zero row. There are 3 non-zero rows, so the rank is equal to 3. Suppose this is also 0, we say the rank is what? 2. Okay, please listen again. It's a very good question. So a matrix given using elementary transformation method. Okay, elementary transformation method. First row, first element, we have to make it as 1, 1. So you can practice in different ways. I said, and you see that your final, this some entries may be different, but everyone will get the rank as what? 3. Okay, so you can practice in any different methods. So I said you can make it as 1 in different ways. You can interchange these two, right? You can interchange these two, change the sign. You can subtract these two. That's what we did here. You can add these two and interchange. There are different methods. Okay, first row, first element 1. Other two, how we made 0? 2 minus 2. Multiply by 2 and subtract. Here, minus 1 plus 1. Just add it, right? We got 0. First row, first element 1. Below that 0. Here, 1. Already it is 1. Below that, you make 0. Very simple. Minus 1 plus 1. Just add it. You are getting like this. Then, 3 lines. The last 3 steps you must write. It is in echelon form. And the number of non-zero rows, here number of non-zero rows, 3. Therefore, rank of this matrix is what? Rank of the matrix is 3. Okay. So these are the steps. It is in echelon form. Number of non-zero rows 3. So rank is equal to 3. Okay. So that you can note down. Now, look at this question. It looks a little lengthy one, right? But it's a very simple question. What is the order of this matrix? How many rows? 4 rows, right? 4 rows and 3 columns. So rank is either 3 or less than 3. First row, first element, it is 1, right? Already it is 1. So I'm not going to do that fully. Just to tell you how to do. First row is 1, 2, minus 1. 1, 2, minus 1. What's the second row here? 3, minus 1, 2, right? 3 minus 1. What's the third row here? 1, minus 2, 3. And the last row is 1, minus 1, 1. Method, you know. What's the method? First row, first element 1. Yes, it is already 1. We want to make all these zeros, right? We want to make all these zeros. How can you make 0? 3 minus 3. 3 minus 3. What step you write? R2 is R2 minus 3R1. 3 minus 3. So R2 is R2 minus 3R1. 3 minus 3. So you can write that step. How can you make this 0? This one only you have to use. 1 minus 1. 1 minus 1. So R3 is R3 minus R1. This one, how can you make 0? Same method. 1 minus 1. R4 is R4 minus R1. Okay, if you do that, you will get this step, you will get, right? You will be getting this step. Now, second row, second element 1 we make, right? Second row, second element you make it as 1. But before that, the third part, here, the third one, you have 0, 4 and minus 4, right? Minus 4 and 4. So the 4 is common. So you can divide by 4, then you can interchange and change the sign. Okay, you can interchange that to R2 and R3 interchange. So this is, when you divide by 4, this become minus 4, 4. If you divide by 4, you will get minus 1 and 1, right? Minus 1 and 1. This is the third row. Interchange, it will go up. 0, minus 1, 1 will go up. Then you change the sign. Multiply by minus, you will get this as plus 1 and this become minus 1. Okay, anyway, you can make it as 1. Then after that, below that, the elements you can make it as 0. And finally, you count how many non-zero rows. And last one you see, here 0, 0, 1 and here 0, 0, minus 1. Here and all you got it correct, right? 1, 2, minus 1, 1, 2, minus 1. Then below that 0, 1, minus 1. First row, first element 1, below that 0. Second row, second element 1, below that 0. Third row, third element 1, below that you make it as 0. Before that you don't count 1, 2, 3, 4, no, wrong. First non-zero number, below that you make it as 0. So minus 1 you make it as 0. How can you make it? Very simple, just add it, right? So first row 1, 2, minus 1. Second row 0, 1, minus 1. Third row 0, 0, 1. Last 0, 0, minus 1. Now last row we want to make it as 0. So what we do here? R4 is R4 plus R3. R4 is R4 plus R3. Add these to 0 plus 0, 0. 0 plus 0, 0. Minus 1 plus 1, 0. It is in echelon form. Number of non-zero rows equal to what? 3, right? So you can say the rank is also 3. Okay, if we are thorough with this one, then the next will be very, very easy. Next, what I said, how to find inverse using Gauss-Jordan method. There also same thing we are going to do. We reduce it into echelon form. Okay, we reduce it into echelon form. Look at this sum, very simple. So earlier I said no. So given matrix you take it as A, but you find A bar I. A you write first, put a line I 1 0 0 1. Reduce it into echelon form. Later you convert it into unit matrix 1 0. Like this you make, so that this will change, because when you multiply by 2, everything you multiply by 2, right? If you add everything, just one line is there. Remember, there is no line, this is a matrix, that's all. Then finally whatever you get here, that is the inverse of what? A. So if you know the previous one what I taught, it will be easy only. So see how we are writing the solution. So A is given, a matrix given, right? A is given, you write A bar I2. A is 2 minus 1. A is given what? 2 minus 1, 5 minus 2. Bar I is 1 0 0 1. So first row, first element we want to make it as what? 1. Column you cannot use, only row you can make. How can you make it as 1? Yeah, 2 and 5, that's all. Nothing is common, you can't divide it. So if you multiply by 2, you'll get what? 4. 5 minus 4 is 1. So what you can do first? First you can make this as 1. So 5 minus 4. So R2 is R2 minus 2 times R1. Multiply by 2 and subtract. Multiply by 2 and subtract. So you are getting 2 minus 1, 1 0. First row no change. So multiply by 2. 2 2s are 4. 5 minus 4 is what? 1. Then minus 2. This minus 2 times this, 2 into minus 1 is minus 2, so plus 2. You will get what? 0, right? You are getting 0. Then 0 minus 2 into 1, 0 minus 2, minus 2, and 1 minus 2 into 0 is 0. So you are getting what? 1. So like that this step you are getting. First row, now we want 1 here, right? So next what you can do? Interchange first row and second row. Interchanging first row, second row. So 1 0 minus 2 1. This is right below. 2 minus 1 1 0. First row, first element 1. Below that we want to make what? 0. How can you make 0? 2 minus 2. 2 minus 2. So first row write as it is. 1 0 minus 2 1. 2 minus 2. So R2 is R2 minus 2 R1. Multiply by 2, subtract 2 minus 2 0. Minus 1 minus 2 in anything, 0, no, it won't make change. Minus 1. 1 minus 4. 1 minus, so it becomes plus 5, right? 0 minus 2 into 1, it is 2. So minus 2 will get. So now listen here. I said you want to make it as a unit matrix 1 0 0 1. So change the sign of last term. Last step you change the sign, that is R2 is minus 1 R2. Second row you change the sign. First row write as it is 1 0 minus 2 1. Change the sign 0 1 minus 5 2. Just to draw lines here after two elements. Now this is identity matrix, right? This is identity matrix. What you get here, this is inverse of A. Okay, so like this you can find inverse. But when you do the 3 by 3 questions, it takes some time, so you have to do very carefully. Okay, so in this case you are getting minus 2 1 minus 5 2, and that is the A inverse. Okay, hope you understood this. Now we see another question in 3 by 3. 3 by 3 matrix given, so you have to use I3, right? I3 you have to use. Look at this. We'll go through the steps here. So first given matrix is A, you find A bar I3, right? A bar I3. So first row, first element here what? 1 only, right? First row, first element is 1. I want to make this 0. How can you make 0? 1 minus 1. So what step you write? R2 is R2 minus R1. This 6, how can you make 0? 6 minus 6. 6 minus 6. So R3 is 6 minus 6. So R3 is R3 minus 6 R1. R3 minus 6 R1. So in that case you will be getting these steps. Okay. So here writing one after the other. So but better you can write this condition. Below that you can write the second condition. Okay. Now listen. First row, first element is 1. Below that zeros. Second row, second element already 1. I want to make this as what? 0. This 4 I want to make what? 0. 4 minus 4. 4 minus 4. So what step you write? R3 is R3 minus 4 times R2, right? 4 minus 4. So it won't affect the first. Okay, so when you do that, you will be getting this step. Now listen, first row, first element 1, below that zeros. Second row, second element 1, below that 0. Third row, third element 1. It is in echelon form, but that is not enough here to find. Rank means it's okay. But to find the inverse, I said you want to make this part as what? Identity matrix. Some more changes, right? So diagonal 1, here 0, but these 3 elements also you make 0, here 0, here 0, right? But here this already 0, this one minus 1 I want to make 0. So use this one, 1 plus 1, this 1 plus 1, if you add these two you will get what? 0. So what step you do? R2 is R2 plus R3, R2 is R2 plus R3, so that the minus 1 become 0. R2 is R2 plus R3. You will get this step, you will get. Now still one more change, right? We want to make the first matrix what? Identity matrix. Still one change. This minus 1 we want to make 0. So this 1 you have to add. So R1 is R1 plus R2. R1 is R1 plus R2. So if you add these two, so this also become what? 0. So now you are getting, so here I put as 1, but you change it as what? 0. It is 0. So you will be getting, this will become identity matrix, and this will be the inverse. Okay, so please do this correction. It is not 1, you make it as what? 0. Okay, and the resulting one, this is the inverse. Once you convert this into an identity matrix, what do you get here? Earlier it was the identity matrix, right? But when you make the changes, it affects this, and this is the resulting A inverse. Okay, so like this you can find A inverse. Similar question 1. Again the first element is what? 1. Make other two elements what? 0. 2 minus 2. And this one you can make 0 very easily. How? 1 minus 1, right? 1 minus 1, 0, you are getting this step. Now first row, first element 1, below that 0. Second row, second element is 1. I want to make this 0. How can you make this 0? Minus 2 plus 2. Minus 2 plus 2. So R3 is R3 plus 2 times R1. Right, multiply by 2 and add it, because minus 2 plus 2. So R3 is R3 plus 2 times this. 2 into 1 are 2. So I add it. Minus 2 plus 2 is what? 0. So you will get this step, you will get. This element we want to make it as 1 plus 1. It minus 1 we have. We want to make it as plus 1. What do you do? Change the sign throughout. Just to change the sign. So you will get this step. But this is not enough. For rank it is okay. But to find inverse, we want to make this as a what? Unit matrix. So first you start from here. This minus 3, make it as 0. Here we have 1, no? So minus 3 plus 3. Minus 3 plus 3. So multiply by 3 and add it. So R2 is R2 plus 3 times this. You multiply by 3 and add with this. Minus 3 plus 3. So you'll get 0 here. Okay, so that's it. Then how can you make this 3 0? 3 minus 3. This one you are using now. Earlier we used this one, right, to make these numbers 0. So same way, to make these numbers 0, you make this one. Minus 3 plus 3. And here this 3 minus 3. Okay, so R1 is R1 minus 3 times R3. Okay, so we'll get this step. Now, still one more. This 2 we want make it as what? 1. Sorry, 0. For that, make use of this one. So what you have to do? 2 minus 2. Right? So R1 is R1 minus 2 times R2. Multiply by 2. Then you subtract this. 2 minus 2. So when you do that, this become what? Unit matrix. And what you get here, that is the inverse. Okay, so you are getting A inverse like this. So but these type questions you have to practice more. So if you practice, definitely you can do the sums. Okay, homeworks are given, so practice these questions. After that, practicing well, you try to work out the homeworks. See you in the next session.